In this video, I'm going to talk about latent heat. And in order to understand latent heat, first you need to understand the definition of phase in chemistry and physics. And here we define phase as a macroscopic state of molecule. So which means that we don't care about specific each molecule, but as a whole, we characterize the molecule or state. Let's use an example of water. So you can say that water has a 3 phases. So that's how you use the word phase, and which is ice, liquid water, and vapor. If you think about the water, these 3 are same molecule, but macroscopically, these are different phase. So that is why you can say that water has a 3 phases. And the important point is when a phase changes, for example, from ice to water, extra heat or energy is needed, and which is called latent heat, which is what we are talking about. The important things to understand the latent heat is heat and temperatures are too different. Excuse me. The pen setting is too different parameter. So for example, if you plot the ice, temperature ice on a constant heating, if you have heat, and this is time, because this is a constant heating, accumulated heat is going to be like this. But if you measure the temperature, so because ice is less than 0 Celsius degree, you can imagine that the temperature of ice is getting increased as you heat this ice. But when the temperature of the ice hits 0 Celsius degree, although you keep heating the ice, you have this plateau, then you are going to see temperature increasement like this. And this is what we call latent heat. So it's pretty easy to understand, I guess. So, but there are several things that you better understand, which is the unit. Because this latent heat, during the latent heat process, you don't see any temperature increase. So the unit of the latent heat is Joule, which is just energy. And the specific latent heat is the latent heat per mass. So the unit is going to be Joule per kilogram. And the unit the unit of the molar latent heat, basically the latent heat per 1 mole. So this unit is going to be Joule per mole. So these things are only things that you need to remember in order to solve the problem of latent heat. So let's solve a question of a latent heat using this one. So the question is, in a cup, you have a 10 grams of ice. So you have ice, which is 10 grams. You better convert this as a standard unit, which is kilogram. So this is the ice. And the temperature is negative 20 Celsius degree. And you pour in the cup warm water. The initial temperature of the water was 30 Celsius degree. And here we don't know the amount of water. When ice completely melted, the final temperature of water in the cup was 10 Celsius degree. How much water did you add to ice? So we don't know this is water. So let's say that this is X kilogram. And the original temperature was 30 degree. And in the end, the temperature is going to be 10 Celsius degree. And we need to obtain this X. So in this situation, you need to understand is the Q down equals to Q up, which means that this is basically this water is giving out the heat, and this ice is going to receive the heat. And as a result, the ice and water reach to a temperature of 10 Celsius degree. In this case, you can write the equation of Q down equals to Q up. And for Q up, which is ice, can write as, so if you imagine this process, the temperature time diagram is again going to be like this, 0. So this ice went through 3 processes. The first process is the rising temperature of ice from negative 20 Celsius degree to 0 Celsius degree. Let's say ice, and you need to multiply by specific heat of ice. Then you go through the latent heat process, which can be calculated as mass multiplied by latent heat. Then, as a third process, mass multiplied by T, water, and specific heat of water. You plugged this M in. Now you plug this number value into this one, 0.01 kilogram. And in this first process, the delta T is going to be 20. And the specific heat of ice is 2093. And again, you want to plug this value into this M. And the latent heat is 334. Remember that this is kilojoule, and the other things is just joule. So don't forget to multiply by 3 so that you can have all true in this equation. And as a last process, you are again going to 0.01 for m, and the delta t is from 0 to 10 Celsius degree. So it's going to be 10 multiplied by this water specific heat, which is 4183. And you may need to use the calculator, but if you calculate this up, you're gonna get 4176.8 joule. And then you wanna think about Q down, which is from this process. Again, Q down is M T down water multiplied by specific heat of water. And here the delta T is 30 subtract by 10 Celsius degree. And M is not known, so let's put X here. X multiplied by 20 multiplied by 4831. And this is going to be joule. Because this value and this value are same, X equals to 4176.8 divided by 4183 divided by 12, which is 0.0499. And this we use here as a standard unit. So this is going to be kilogram. And if you want to convert this to gram, this is going to be 49.9 gram. So I hope you find it easy, and let me know if you have any question in the comment. See you next time.